Page 325, number 45, talks about bridge builders and having to make rivets that are larger than the hole fit. And one of the ways they can do that is to cool them so they contract, then fit into the hole and expand as they warm up. And in order to get the rivet into the hole, we have to have a delta L of 0.002 to make it the same size. And we would use the formula alpha equals delta L over L1 times delta T. And what they want to know is what temperature they need to be cooled at. So what we have to do is solve for delta T and then adjust from 20 degrees. The alpha for steel is 12 times 10 to the negative 6. First thing we got to do is move delta T over to this side of the equation by multiplying and then dividing by alpha. So we're going to rearrange this equation to look like this. Delta T equals delta L over L1 times alpha. And to substitute the numbers in, we'd have 0.002, and L1 is 1.225 times our alpha of 12 times 10 to the negative 6. And when we multiply that through, we get a delta T of 136 degrees C. Now, to work with positives and negatives here, we really want to make it smaller. So this value becomes negative, which means our final answer is negative, which means the rivet needs to be cooled to, cooled a total of 136 degrees C. Now, it started at 20, so we would add 20 to that, and that means the final temperature would have to be cooled to 116 degrees Celsius below zero. That could be achieved with liquid nitrogen. There's the final answer.